Alright, so this is section 6.4, which is on small sample tests for a population mean. So let's start with an example. So because we're talking about small sample tests, that means the sample size is less than 30, we have to assume our sample comes from a normal distribution. So let's assume body temperature of a person is normally distributed. Okay, and then let's take 6 measurements from a person. So the measurements are 99.7, 98, 100.3, 99.5, 98.8, 100.7. All these are in Fahrenheit. Using calculator, we can figure out the sample mean is 99.5 and the sample standard deviation is 0.986. So because the sample mean is 99.5, we can form a hypothesis test. We can assume we want to prove this person actually has a fever, which means the population mean is greater than 98.6 degrees. So this means fever. So that's what we want to prove. So that's our alternate hypothesis. And the null hypothesis is the opposite. So means mu is less than or equal to 98.6, which means no fever. So we can draw our null distribution. Because we're doing small sample, so the null distribution is not normal distribution anymore. So instead of normal, it is the t distribution with degrees of freedom. Because the sample size is 6, so the degrees of freedom is 6 minus 1, which is 5. The mean of the null distribution is still the number appears in the hypothesis test, so it's 98.6, and our sample mean is 99.5. Sorry, 99.5. So instead of z-score, what we calculate instead is what's called a t-statistic. But the calculation is exactly the same, so we take the sample mean, subtract 98.6, divided by the standard deviation, which is the sample standard deviation, divided by the square root of sample size. So what we get is 2.236. The difference with t-table is we don't have all the values we need. So now the t is equal to 2.236. Now we look at the row with degree of freedom 5. Notice that t is equal to 2.236. That's between these two numbers. That means our p-value is between these two numbers. So the p-value is between 0.05 and 0.025. So we don't know the exact p-value, but this is good enough to make our conclusion because we know p is less than 0.05, so we know we can reject h0 and conclude that this person has a fever. Alright, so let's do a different example. So let's move the table around. Let's erase these things. Okay, so let's say x1, x2, all the way to x6 came from a normal distribution. Okay, their values are 39.03, 38.997, 39.012, 39.008, 39.019, and 39.002. Anyway, we can figure out the sample mean is 39.01133, and the sample standard deviation is 0.011928. Alright, so we can form a hypothesis test. So the null hypothesis is going to be the population mean is equal to 39, and the alternate hypothesis is mu is not equal to 39. So we can draw our null distribution. So the degree of freedom, because the sample size is still 6, so the degree of freedom is 6 minus 1, which is 5. So the mean is 39, and the sample mean is 39.01133. So the t-statistic is equal to 39.01133 minus 39 divided by 0.011928 divided by the square root of sample size. So this is equal to 2.327. Because the degree of freedom is 5, so we can look at the same row. So 2.327 is still between these two numbers. But notice that this is a two-sided test. So the p-value is equal to the areas of the two tails added together. So instead of having between 0.025 and 0.055, we need to multiply the p-value by 2. So p is between 0.1 and 0.05. Because p is not less than 0.05, so we cannot reject h0. So we cannot make a conclusion. Definitive conclusion. Okay, so let's do a same example, but now if we know the true value of the population standard deviation, then we use population standard deviation instead of the sample standard deviation, and we use z instead of t. So let's copy the same number from the previous example. So the 6 numbers are 39.03, 38.997, 39.012, 39.008, 39.019, and 39.002. And the sample mean is 39.01133, and the sample standard deviation is 0.011928. But now we are given that the population standard deviation is equal to 0.01. So the null distribution, because we know that the value of the population standard deviation, so we use the z instead of t. So the null distribution is normal distribution with mean 39. Oh, I forgot to write down the tests. The tests are the same. The mean is 39, and the variance is the population variance divided by the sample size, which is 6. So the mean is 39, and x bar is 39.01133. So the z score is equal to 39.01133 minus 39 divided by 0.01 divided by root 6. So the z is equal to 2.78. And if we look at the z table, so the p-value is equal to, so 2.78 gives you 0.0027 from the table, but because it's two-sided test, we multiply the p-value by 2. So p is equal to 0.0054, which is less than 0.05. So in this case, we can reject H0 and conclude that H1 is correct. All right.